The National Aeronautics and Space Administration, NASA, is an agency of the United States federal government responsible for the civilian space program, as well as astronautics, aerospace research. STS stands for Space Transportation System. The STS is made of the orbiter, the solid rocket boosters, and the external tank. The John F. Kennedy Space Center, KSC, is one of the 10 National Aeronautics and Space Administration field centers and is NASA's center of excellence for launch and payload processing systems. Located on the east coast of Florida, KSC is bordered to the Cape Canaveral Air Force Station, where unmanned rockets are launched from Complex 1 through 38. The Kennedy Space Center was built for Apollo to go to the moon and was adapted for the Shuttle, and it is Complex 39, pads A and B.
The Space Shuttle became the major focus of NASA in the late 1970s and 80s, planned as a frequently launchable and mostly reusable vehicle. 5 Space Shuttle orbiters were built by 1985. The first to launch was Columbia on April 12, 1981, followed by Challenger, Discovery, Atlantis, and Endeavour.
The Shuttle carrier aircraft, SCA, were 2 extensively modified Boeing 747 airliners that NASA used to transport Space Shuttle orbiters.
The Orbiter Processing Facilities, or OPFs, were one of 3 hangars, like a custom-made garage for the orbiters. This is where they underwent maintenance between flights. All 3 OPFs were located at the NASA Kennedy Space Center in the Launch Complex 39. When the shuttle mission was completed, the orbiter was towed from the shuttle landing facility to its assigned OPF, where it spent several months, typically less than 100 days, being prepared for the next mission. Any remaining payload from the previous missions were removed, and the vehicle was fully inspected, tested, and refurbished.
The Space Shuttle Solid Rocket Boosters, or SRBs, were the first solid fuel motors to be used for primary propulsion on a vehicle used for human spaceflight. It provided the majority of the Space Shuttle's thrust during the first 2 minutes of flight. After burnout, they were jettisoned and parachuted into the Atlantic Ocean, where they were recovered, examined, refurbished, and reused. The rocket fuel was manufactured in Utah and brought in on a train. A Space Shuttle External Tank, ET, was the component of the Space Shuttle launch vehicle that contained the liquid hydrogen fuel and liquid oxygen oxidizer. During liftoff and ascent, it supplied the fuel and oxidizer under pressure to 3 Space Shuttle main engines in the orbiter. The ET was ejected just over 10 seconds after MECO, or main engine cutoff. Unlike the solid rocket boosters, external tanks were not reused. They broke up entering the atmosphere before impact in the ocean and were not recovered. The contractor for the external tank was Lockheed Martin. The tank was manufactured in New Orleans, Louisiana, and was transported to Kennedy Space Center by barge.
The Vehicle Assembly Building, or the VAB, was designed to assemble large space vehicles. It was originally built in 1966 to allow for the vertical assembly of the Saturn V rocket. The building covers 8 acres and encloses almost 130 million cubic feet of space. There are 4 bays located inside the building, which are the 4 largest doors in the world. Each door is 456 feet high. It has 7 vertical panels and 4 horizontal panels, and it takes 45 minutes for the doors to completely open or close. To lift the components, the VAB housed 5 overhead bridge cranes, including 2 capable of lifting 325 tons, and 136 other lifting devices. It was renamed Vehicle Assembly Building after the Apollo program and was used to make the Space Shuttle orbiters and their solid rocket boosters and the external fuel tanks. Once assembled, the complete Space Shuttle transportation system was moved onto the Mobile Launcher Platform and the Crawler Transporter for transport to the Launch Complex 39, Pad A or B.
The crawler transporters are a pair of tracked vehicles used to transport spacecraft from NASA's Vehicle Assembly Building, VAB, along the crawlerway to Launch Complex 39. They were originally used to transport the Saturn IB and Saturn V rockets during the Apollo Skylab and Apollo Soyuz programs. They were then used to transport space shuttles from 1981 to 2011. The crawler transporters carry vehicles on the Mobile Launcher Platform and after each launch return to the pad to take the platform back to VAB. It takes a team of nearly 30 engineers, technicians, and drivers to operate the vehicle. The crawler is controlled from two control cabs located at either end of the vehicle. It travels along the 3.5 miles crawlerway at a maximum speed of 1 mile per hour loaded or 2 miles per hour unloaded. The average trip time from the VAB along the crawlerway to the launch pad is about 5 hours. Each crawlerway is 7 feet deep and covered with Alabama and Tennessee River rocks.
The launch towers at each pad contained a two-piece tower access system: the fixed service structure and the rotating service structure. Now, the fixed service structure permitted access to the shuttle via a retractable arm, the white room, and a beanie cap to capture vented LOX, the fuels from the external tank. Now, the rotating service structure contained the payload checkout room, which covered the payload bay and offered clean access to the orbiter. It also protected it from the elements and from winds up to 60 knots. It also provided access for technicians to perform detailed checkout of the vehicle and necessary umbilical connections to the pad. It contained 3 elevators, 2 self-propelled platforms, and 3 fixed platforms. Payloads to be installed at the launch pad were independently transported in a payload transportation canister, then installed vertically at the payload changeout room. Otherwise, payloads would have already been pre-installed at the orbiter processing facility and transported within the orbiter's cargo bay. A sound suppression water system was added to protect the space shuttle and its payload from the effects of the intense sound wave pressure that's generated by its engines. An elevated water tank is near both pads. It has a 290-foot tower and stores 300,000 gallons of water, which was released onto the mobile launch platform just before engine ignition. The water muffled the intense sound waves from the engines. Due to heating of the water, a large quantity of steam was produced during the launch, not smoke.
Fueling the external tank takes place on the pad. The large cryogenic tanks located near the pad stored the liquid hydrogen and liquid oxygen, LOX. The highly explosive nature of these chemicals required numerous safety measures at the launch complex. The pads are located 8,730 feet away from each other. Before tanking operations began and during launch, non-essential personnel are excluded from the danger area. The 4-story Launch Control Center is located 3.5 miles away from Pad A, adjacent to the Vehicle Assembly Building for safety. The 3rd floor has 4 firing rooms, each with 470 sets of control and monitoring equipment. The second floor contained telemetry tracking, instrumentation, and data reduction computing equipment. The LCC was connected to the mobile launchers by a high-speed data link, and during launch, a system of 62 closed-circuit television cameras transmitted to 100 monitor screens in the LCC.
3, 2, 1. Liftoff! Liftoff of the Space Shuttle! It takes only 7 seconds for the shuttle to clear the tower, and then all controls transfer to the Johnson Space Center in Houston, Texas.
2 minutes after launch, the solid rocket boosters jettison away from the orbiter and fall back to Earth to be reused. After reaching 17,500 miles per hour, the shuttle jettisons the external tank to fall back and burn up as it enters our atmosphere. You are now in low Earth orbit. Here, the astronauts do their experiments, they do spacewalks, and deploy satellites. The astronauts work on the International Space Station, and it is the biggest artificial satellite in low Earth orbit. Its first component launched into orbit in 1998, and the ISS is now the largest artificial body in orbit and can often be seen with the naked eye from Earth. The ISS consists of pressurized modules, external trusses, solar arrays, and other components. The ISS components have been launched by Russian Proton and Soyuz rockets, as well as our American space shuttles.
The shuttle landing facility is an airport located on Merritt Island in Brevard County, Florida. It is a part of Launch Complex 39 at the Kennedy Space Center, and was used by NASA's Space Shuttle for landing until the program's end in 2011, as well as for takeoffs and landings for NASA's training jets and civilian aircraft such as the Shuttle carrier aircraft. A local nickname for the runway is the Gator Tanning Facility, as some of the 4,000 gators living at the Kennedy Space Center regularly bask in the sun on the runway. The shuttle landing facility covers 500 acres and has a single runway. It is one of the largest runways in the world at 15,000 feet and is 300 feet wide. Additionally, the shuttle landing facility has another 1,000 foot of paved overrun at each end. The mate-demate device was used when the shuttle was transported by the shuttle carrier aircraft and was located just off of the runway. After Space Shuttle Columbia became the first shuttle launched into orbit on April 12th of 1981, it returned and landed at the Edwards Air Force Base in the California desert. The airbase's immense lake bed was an important factor on its selection and is continued to serve as the primary landing area for the Space Shuttle until 1991. At that time, the Kennedy Space Center in Florida was favored. This saved the immense cost of transporting the shuttle from California back to Florida. But Edwards Air Force Base and White Sands Space Harbor in New Mexico continued to serve as backups for the duration of the shuttle program. The shuttle landed at Edwards as recently as August 9th of 2005.
Welcome home, Space Shuttle. Let's cool you down from re-entry, pull you back to the orbiter processing facility, and start all over again.